Hey guys, go ahead and get out your notes sheet for x and y-intercepts.
Hopefully that didn't freak you out too much. I just figured you guys were sick of me saying the same old thing, so I changed it up. So first thing we're going to talk about is the actual definition of x and y-intercepts. And so an x-intercept is the point where a graph crosses the x-axis, and then a y-intercept is the point where a graph crosses the y-axis. And I know we've kind of talked about this a little bit before, but now we're going to look at it in terms of graphing. So you see a picture down below. The blue line is the line graphed, and then they're showing you the spots of the x and y-intercept. Here's another look at a graph of a line, and the black line's graphed here, and right here at the point 2, 0, that would be your x-intercept, and then your y-intercept is right here at 0, -1. So again, that's just visually seeing the x and the y-intercepts on a graph. So what we're going to do is we're going to actually go ahead and look at these graphs, and we're going to name the x and the y-intercepts as ordered pairs, and then we're going to kind of look at those ordered pairs and see if there's anything we can conclude from them. So for graph 1, our x-intercept is right here at -1, 0. For graph 2, our x-intercept is at 2, 0. And for graph 3, the x-intercept is at 4, 0. We're going to take a look at the y-intercept. So on graph 1, my y-intercept is at 0, 2. Graph 2, 0, -1. And graph 3, 0, +1. So if you want to take a second and look at these and kind of figure out similarities and difference between the x-intercepts for each graph and the y-intercepts for each graph, that's going to help us with determining our rules and what we can do later to use these. Okay, so when you were looking at your x-intercepts, did you notice what they had all in common? This is something, again, that's going to help us later whenever we need to use these to graph. What you should have noticed for each of those is that the value of the y is always 0 for an x-intercept. And for the y-intercepts, what they have all in common is that the value of x is 0. So we're going to kind of talk about that in a second again. Okay, so how can we use the x and y-intercepts to graph lines? Well, based off of what we just discovered, you can find an x-intercept of an equation by plugging in 0 for y and then solving for x. So since every x-intercept we saw from our graphs, the y value was 0, that means even as equations, that when we want to find an x-intercept, that means y is 0. On the opposite end, if you want to find a y-intercept of an equation, you're going to plug in 0 for x and solve for y. So again, if you look at all of those y-intercepts we wrote out, the value of x for each of these was always 0, which means for an equation, if you want a y-intercept, we just plug 0 in for x. Okay, so these are your 3 steps we're going to use to graph using your intercepts. Step 1 is to plug in 0 for y and solve for your x-intercept, and that's based off of what we have just determined works, that when you have an x-intercept, the value of y is always 0. Step 2 is to plug in 0 for x and solve for the y-intercept, since again, on a y-intercept, the value of x is always 0. And then step 3, once you know your x and y-intercepts, you can plot them as points and connect them and make your line. Alright, so we have 4 practice ones we're going to go ahead and look at and do together. And so your first one here is 3x minus 4y equals 12. Now, again, based off of what we've already determined, if we know we have an x-intercept, then the value of y is 0. So if you look over here, I took the equation 3x minus 4y equals 12, but I changed y to 0, since if I'm looking for an x-intercept, y would be 0. So basically when you solve, that would cancel. We're left with 3x equals 12. We're going to divide by 3, and our x-intercept would automatically be 4. So in my table down here, I know x is 4 when y is 0. And then when I want to solve for my y-intercept, that means that x is 0. So I plugged a 0 in for x, and that's basically going to make 3 times 0 go away. You're left with -4y equals 12, and you'll divide by -4, and then the y-intercept is -3. So when x was 0, y was -3. Now, I have those 2 points, so I'm going to go ahead and plot them on my line. I have 4, 0 for my x-intercept. And then I have 0, -3 for my y-intercept. And if I connect those two as straight as I possibly can without a roller, that means our line would look something like that. And we're done, and it's just a really fast way to graph. So your second example, 2x plus 4y equals 8. So we'll solve for the x-intercept. Since we want x, again, we put in a 0 for y. We'll have 2x equals 8, and x would be 4. So as an ordered pair, 4, 0, and I'm going to go ahead and graph it right now as well. And then when I want my y-intercept, I'm going to zero out x, and I get 4y equals 8 and y equals 2, which means that 0, 2 is an ordered pair, and I'll go ahead and graph that. Again, once you have those 2 points as your intercepts, you can connect, and I know mine's not that straight, and I'm not going to fix it, you get the point. If you used a roller, it'd be more exact, but connect those points, and there is the graph of the equation that you have. Okay, third example, 5x plus 3y equals negative 15. So for my x-intercept, y is 0, so that goes away. We get 5x equals negative 15. Divide, and we would get x equals negative 3. So now I know that negative 3 is my x-intercept. And when I solve for my y-intercept, I'm going to put a 0 in for x, and I get 3y equals negative 15, and then y would be negative 3. Or I'm sorry, negative 5, which means 0, negative 5 is also a good spot to put a point. Sorry, I had to shrink my screen a little so I could see 0, negative 5. And then I'm going to go ahead and connect as straight as I can. And now I have my line for 5x plus 3y equals negative 15. Now, hopefully you've realized this is a little bit faster than what we did in class where we solved for y and made a table. This is a second option you have for graphing. You could still solve for y and make a table for all of these. It would work. But this is just another option when you have numbers that can easily be divided to give you exact x and y intercepts. So we'll take a look at our last one. So your last equation is 2y equals 3x minus 6. Now this one's format is a little bit different. For all of the other three, you had x and y on the same side, and that's called standard form. This one, the x and y are on different sides. Technically, you could solve as is and leave it like this and still 0x and 0y and solve. But what I'm going to do is I'm going to make this equation be in standard form by basically saying, well, let me move my 3x over. And right now it's a positive 3x, so if I was to subtract it from both sides, then I would have a negative 3x plus 2y equals 6. Or equals negative 6, and now you have that standard form that you can use to match the rest of these, and it's typical to use standard form with x and y intercepts. So from here, if I want my x-intercept, I'm going to go ahead and zero out y. I'll have negative 3x equals negative 6. X would be 2, so I'm going to go ahead and put my x-intercept at 2, and then my y-intercept means get rid of x. Solve for y, and you would get y equals negative 3. You could put your point and 0, negative 3, and then you're going to go ahead and connect, and you've got your last line. So hopefully this was just a nice alternative method to graphing. You typically use this when you have equations in standard form, and when the number in front of x and the number in front of y, and then your constant that's all by itself. If you look at your constant and think of being able to divide it by your coefficient of x and y, if you get those nice whole numbers, this is the best method to use just because it's fast and easy. So I have a couple practice ones for you guys just to find the x-intercept without the graph. So if you can take a look at the equation and see which one of these it would be, go ahead and press pause and then press play when you're ready to check. Your x-intercept should have been 8, 0 for this one. Go ahead and pause and find the y-intercept of your equation here and press play when you're ready to check. And your y-intercept here should have been 0 and 4. And here's your last one. What would the y-intercept of x equals 3 be? This one's going to make you think a little bit, so we'll see who can figure this one out. So this one was a little trickier. The answer is actually none here. And so what I did is I took x equals 3 and I used identity and put a 1 in for x. And since there's no y, I said that had to have been 0y. So I made 1x plus 0y equals 3. And if we're solving for a y-intercept, I got rid of x, which left me with 0 times y equals 3. Now you still would have to technically solve for y, which means you would divide by 0. And if you ever try to divide by 0 on a device, you cannot divide by 0. It actually would say error on your calculator. And that basically means that this does not have a y-intercept. And if I have a little mini graph drawn here, if I want to show that x equals 3 as a line, I'm going to go to the x-axis and go to 3, but then I have to say, well, x is only ever 3. There's no other x value of 3. So where I would see where x is always 3 would actually be this vertical line here right at x is 3. And since it's a vertical line, it's never going to cross the y-axis, so there is no y-intercept. So that was kind of a tricky one. We'll talk about equations like this a little bit later, so you guys will see, but if you figured that out, great job. So just a quick review to kind of tie this all together. An x-intercept is the x-coordinate of a point where the graph crosses the x-axis. And at the x-intercept, the value of y would be 0. Since it's right on that axis, it never goes up or down. The y-intercept is the y-coordinate of a point where a graph crosses the y-axis, and the value of 0 here, or I'm sorry, the value of x here is 0. And again, that's because the line never went left or right. It stayed at the origin for the x-coordinate, but went up or down along the y-axis. And to graph lines using the intercepts, you would need to know what the actual value of the x-intercept and y-intercept is, and you find those by plugging in 0 for y or 0 for x. And lastly, how many ways do we now know how to graph? We have now learned 2 ways. You can solve for y and make a table, or you can use these equations in standard form and just solve for your x and y intercepts and graph that way. So hopefully this all made sense and you like this because it was definitely quicker. It's not always the best method, but it's just one of your options. We will have a third option we'll take a look at pretty soon. And then you guys will be able to actually use any of the 3 methods that you prefer for graphing. I usually say pick the one that you like the best or the one that is easiest for each of them. So I will see you guys soon. Thanks.